Hello everyone, welcome to Basic Electronics Tutorials. In this video, I'm going to take up the first numerical on bridge rectifier with capacitor filter. Let me read out the question first. In a full wave rectifier with a capacitor filter, the load current from the circuit operating from 230 volt 50 Hz supply is 20 milliamperes. Calculate the value of the smoothing capacitor required to keep the ripple factor less than 1%. If you analyze the question carefully, you will note that we have a full wave rectifier with a capacitor filter. The supply voltage is given as 230 volt 50 Hz and the load current is 20 milliamperes. We are asked to find the value of the smoothing capacitor if the ripple factor required is less than 1%. Let us start with the solution part. Let me quickly write down the given values. The input voltage is given as 230 volt. Please note this is the RMS value of the voltage. Further, we are also given the input supply frequency and it is 50 Hz. Then the load current is given as 20 milliamperes and the ripple factor is given as 1%, that is 0.01. We are asked to find the smoothing capacitor value. So now I'll write an equation for the ripple factor which involves the values of frequency, smoothing capacitor and load resistance. Ripple factor equals 1 divided by 4 root 3 multiplied by F C RL. Let this be called equation 1. In equation 1, the value of RF is given, which is 0.01. Frequency is 50 Hz. We are asked to find the value of C and the value of RL is not known. So let us now write an equation for finding the load resistance RL. It is given by VDC divided by IL, where VDC is the DC output voltage. We do not know the value of VDC, so let us write the equation for VDC and it is given by 2Vm by pi. Let me call the equation for RL as equation 2 and the equation for VDC as equation 3. In equation 3, Vm is the peak input voltage and it is given by root 2 into Vs, where Vs is the RMS value of the input voltage. Please note, we are given the value of the RMS value of the input voltage and it is 230 volt. So Vm will be root 2 multiplied by 230. So it is equal to 325.269 volts. Once we find the value of Vm, we can now substitute it back into equation 3 to find the DC output voltage. Let me rewrite equation 3 once again here. I'll substitute the values. So this is 2 divided by pi multiplied by Vm, which is 325.269. Calculating this, will obtain the answer for VDC as 207.0726 volts. This is the average or DC value of the output voltage. Once we find VDC, now we can substitute back into equation 2 to find the load resistance RL. Let me rewrite equation 2 once again here. VDC is 207.0726. IL is given as 20 milliamperes. So the answer for load resistance is 10.3536 into 10 to the power of 3 ohms. Once we find RL, we can now substitute that back into equation 1, which is for the ripple factor. I'll rewrite equation 1 here. Please note, we are asked to find the smoothing capacitor value. So I'll rearrange this equation for the capacitor. So capacitor value is equal to 1 divided by 4 root 3 into F RL into ripple factor. Let us now substitute the values to this. It is 1 divided by 4 root 3 multiplied by frequency, which is 50 hertz, multiplied by RL. The value of RL we just computed and is 10.3536 into 10 to the power 3, multiplied by ripple factor, which is 0.01. Solving for this, we will obtain the answer for the smoothing capacitor as 27 microfarad. This is the answer for this numerical. Well, that is the end of this video. If you like this video, kindly like and share this video and subscribe to my channel for more tutorials on basic electronics. Thank you for watching. Have a good day.